All right, hello everyone. Tonight we're going to be going through lesson three. Should be a pretty quick lesson. I'm thinking should only take about 30 minutes in all, probably less. If you have any questions, feel free to type in the chat. And without further ado, let's go right ahead. So starting off, got to go over the variables. I'm just going to make it brief, categorical, names and labels, quantitative, numbers. Just, remember what they are. You guys have had this drilled into you for the past two lessons. I'm not going to really drill it into you now, but you just have to know what they are. And you got to remember explanatory versus response. Oh. Yes, Mitchell. The homework will update when you do it. It'll just update as you go, so don't worry. Anyway, so explanatory versus response. Explanatory is basically explains the variations of the response variable, and the response variable is just the outcome that is being measured following manipulation by the explanatory variable. So, time for some more fun stuff. All right, so going back, single box plot is really comprised of the five number summary of the minimum, the first quartile, median, the third quartile, and the maximum. And I'm sure you guys have had to view this in Minitab and on the homework and stuff like that. So you guys know what a box plot is. The whiskers represent the lowest and the highest values that are not outliers, and all the outliers are basically represented by an asterisk. So here is a picture of that. You can kind of see the median that's a line right in the middle, the box where it has Q1 at the bottom, Q3 at the top, the minimum way over here, maximum over here, and all these ones that are outside of it are potential outliers. You can calculate this using the IQR method that we'll be going over next. Question with the box plot. Okay. Question is for finding Q1 in something that's not a five number summary, how do you do it? In that case, most likely it's going to be given to you. They're going to just say, all right, this is the minimum, this is Q1, this is the median, this is, as you'll see in a problem that I have later on. However, yeah, if it is a 10 number summary and for whatever reason they don't give it to you, you can just take the average between 2 and 3, and that should get you the 25th percentile. So the IQR method for identifying outliers, basically you have to find the lower fence and the upper fence. So lower fence is you're taking the first quartile and you're subtracting it by 1.5 times the IQR. For the upper fence, you're taking Q3 and you're adding 1.5 times the IQR. And so if there's any observation that is below the lower fence or above the upper fence, then it's considered an outlier. It's just a very easy mathematical way of calculating it. A lot of times you should be able to just eyeball outliers, but for a question where you can't visualize the graph or when they ask for it, it's just something that you should have handy. So, all right. So in the last lesson, we talked a lot about just graphing one categorical variable or one quantitative or even a little bit of two categorical variables. But now we're going to be going into a little bit more detail for that. So one quantitative and one categorical variable, you're going to have a chart. So some examples of this are side-by-side box plots, dot plots, and histograms with groups so that you can, kind of visualize it. It makes sense when you see the graphs and everything. So for side-by-side box plots, it's easy to compare the IQR, the range, and the median. Dot plots and histograms with groups, you can easily compare the central tendency, the variability, and the shape. So those are kind of like the pros and cons to the two different kinds. It's All right, so here's the real meat of the lesson. Two quantitative variables. So for possible distributions for this, it's either going to be a scatter plot, a correlation, or a simple linear regression. So for scatter plots, it shows the relationship between the explanatory and the response variable. The explanatory is always going to be on the x-axis, and the response variable is always going to be on the y-axis. And so here are some very important things to consider whenever you see a scatter plot. Is the strength. Is it a strong relationship, a weak relationship, or somewhere in between? The direction. Is it positive or negative? So is it going from the bottom left hand up to the top right hand, which would be positive, or is it going from the top left hand down to the bottom right hand, which is negative? Form. Is it linear? Something that's very important to take away from this is if it's not linear, then you cannot use a scatter plot. So just remember that. They will try and trick you with this. I know they got me with it. And one last thing is just outliers, because outliers can have a huge effect on scatter plots. So you just have to consider all these things when you're looking at a scatter. So here's an example. You can see it's going from the top left up here, going all the way down to the bottom right. So it has a negative direction. It's pretty strong, just based on the graph. And there aren't really any outliers, and it is linear, so passes those checks. Next up, we have correlation. So correlation is the measure between two variables based on direction and strength. You probably know this as rho or R. Some very important things to know about R. It has to be between -1 and 1. If R is above 0, then it is positive association. If it's below 0, it's a negative association. The closer to 0, the weaker the relationship, and conversely, the closer it is to 1 or -1, the stronger the relationship. Correlation has no unit, and this kilo thing, correlation between x and y always equals correlation between y and x. So for instance, like height and shoe size. If, chances are if someone has big feet, then they're also going to be taller. So, you can inverse that and say people who are taller most likely have bigger feet. Just stuff like that. And so this is a chart. If you don't have it, written down, I highly recommend, you write it down, take a picture. So for this, it's saying, it's trying to gauge how strong it is. So if R is between 0 and 0.2, then it has a very weak relationship. Or you could also, in some cases, say no relationship. It depends, but I'd go with very weak. If it's between 0.2 and 0.4, it has a weak relationship. If it is between 0.4 and 0.6, it has a moderate relationship. If it's between 0.6 and 0.8, it is a strong relationship, and 0.8 to 1 is a very strong relationship. So just going to give you guys a little bit of time, copy it down, take a picture, whatever you need. Just make sure you know the table. All right. So here are some cautions. Okay. The reason why this is all in caps is because my high school teacher yelled this at us every single day. Correlation does not mean causation. So just because there is a correlation does not mean that something is caused by it. For instance, going back to the big feet and height thing. Just because someone has big feet does not mean it's not caused by the fact that they're tall. Me, for instance, I have size 13 shoes and I'm only 5'10". So, riddle me that. R is also very sensitive to outliers. That's why you always have to be careful of them, when you're looking at a graph, because it can very much skew it one way to either make it, a much weaker or much stronger relationship based on whether or not it has outliers. And again, R can only be used with a linear relationship. If it's not linear, you can't use R. All right, moving on. We have simple linear regression. So this is going like all the way back to middle school, high school algebra with y equals mx plus b. You're using a straight line to basically predict what the response is going to be. So just some stuff for that. Both variables have to be quantitative, and it does matter which variable is x and which variable is y. So the formula, you might have seen a few different ways of y hat equals b naught plus b1x, or y hat equals a plus bx. It's all just derived from y equals mx plus b. So y hat is the predicted value of a, b naught or a is the y-intercept, and b1 is the slope. And residuals. So a residual is the difference between an observed y value and the predicted y value. The equation for this is E equals y minus y hat, where y is the actual value of y and y hat is the predicted value of y. All right, so now we're moving on to more than just two quantitative variables. So for scatter plots with groups, it's two quantitative variables and one categorical variable. So the quantitative variables are going to be on the x and y axis, and the categorical is going to be represented on the points. So you can see in this one, it just says variable 1, variable 2 on the axes, and then the categorical is split into young, young-old, and old, and those are differentiated using shape of the dots and color of the dots. So, it might seem a little confusing to read, but it will make more sense as you see more of them. And then there are also bubble plots. So they're used for 3 quantitative variables and 1 categorical. They're fun. They're fun to look at, fun to try and use. As you can see, they've got different quantitative variables and then all these other categorical variables. So I believe it's probably, again, I didn't make this, I just found this online. I believe it's probably sports clothes versus, how much that makes and how much it costs for the clothes. And then I think our last plot for the night is the time series plot. So basically, the time is always going to be on the x-axis, and then the quantitative response to the time is going to be on the y-axis. So you'll generally see this a lot when it comes to stuff that's like changed over time. So if you're looking at global warming, if you're looking at the amount of wildfires that's been happening in California, or like all that stuff that's just over time is going to be a time series plot. I don't think they're going to be very common on your exams or anything like that, but it's just good to recognize them. All right, so on to question number 1. So for this one, you just need to use the IQ. What was the one before scatter plot? You mean residuals? Okay. Yeah, residuals. E is the residual minus the actual value y, y minus the predicted value y. So IQR method. So here's this long string of data. I wrote out what the minimum was, what Q1 was, the median, Q3, and maximum were. So basically, find any outliers. I'll give you a hint. There's more than one. And just write it in the chat when you get it, and I'll give you guys a little bit of time for it. All right, looks like you guys got this, so that's really good. Yep. So here's all my work. The IQR is Q3 minus Q1, which is 15 minus 13, so 2. And then you just find the lower fence is Q1 minus 1.5 times the IQR, which is 13 minus 3, so you get 10. And to find the upper, it's Q3 plus 1.5 times the IQR, which is 15 plus 3, so you get 18. So if there's anything below 10 or anything above 18, it is considered an outlier. So in this case, both 0 and 8 are outliers. So good job. Next up, so here's a scatter plot. I want you guys to just kind of like predict the strength of the linear relationship between x and y, and then kind of like finish this sentence. So as x increases, the predicted value of y blank. I'll give you guys a little bit of time. All right, I think I got you guys for this one. So it's whew, man, I think that's the first. Okay, so a lot of you guys were kind of seeing it. The relationship is very, very weak. It's probably close to 0, and so as a result, as x increases, y doesn't really change. You can't really extrapolate anything from this. It's pretty rough, you know. I imagine if you ever, saw this on an exam, they probably provide you a little bit more context. They might even give you an R value, but oh, sorry if that wasn't clear. Yeah, I was just looking for the strength of the relationship and how an increase in x affects y, which doesn't. So fun times. All right, next up, something kind of similar. Okay, so this one might be a little bit better. So in this scatter plot, I want you to find the direction. So is it positive or is it negative? Find the form. Okay, you guys should already know that one since you're using it. And then the strength, is it weak, moderate, strong, stuff like that. So I'll give you guys a little bit of time. All right, that was fast. You guys are killing it again. Yep. Positive and the strength. It is strong. That shouldn't say moderate. It's pretty strong and it is linear. So way to go. All right. So which value of R signifies the strongest relationship? Is it A, negative 0.99, B, 0.98, C, 0.01, or D, negative 0.12? Yep, it's A, guys. basically, since it's the closest to 1, even though it does have the negative side, it doesn't matter because it's -1 to 1. So they will definitely try and trick you up on an exam like this. They might even have the, you know, something exactly like this where it's negative 0.99 and 0.98 and try and get you. If they ever put negative 0.99 and 0.99, then they would be equal. It's you can basically think of it as an absolute value where the negative sign doesn't matter. It's just saying that it's a negative relationship. So you could in this you could say it's super strong because it's just that close to 1. You could just whenever it asks you for R, you can just absolute value it and see which one is closest to 1 with an absolute value. That's all you gotta do. All right. So this one is very tricky. I'm gonna see. This is me seeing how closely you guys are paying attention. So basically, you have this nice scatter plot here, and so what is the main difficulty with this? Oh, way to go, Chris! You ruined it for me. Oh God. Yep. Damn. You guys really were paying attention. Oh. All right. Yep. So it's got to be linear. If it's not linear, you can't use it for Pearson's. uh, thanks, Mitchell. You always make my day. All right. So this is. Oh, sorry. So Matt was nonlinear. So yeah. Oh boy. Okay. 6. So I'm giving you the residual. It's y hat equals 11 plus 5x. So if x is 2 and y is 18, compute and interpret the residual. So I'll give you guys a little bit of time for this. All right, you guys got this one too. It is in fact -3. So if you were to plug in the x equals 2 to the 5, then you get y hat equals 21. Then you just take the 18 that was actually found minus the 21 that was predicted, and you get a residual of -3. So good job, guys. All right. So this is number 7. So describe the relationships between height, weight, and biological sex for this nice graph here. So I'm pretty sure the black circles are women and the red boxes are men. And you have weight on the y-axis and height on the x-axis. Okay, so sorry if the question seems a little vague. Basically, I'm trying to get like the relationship between height and weight first. So as one goes up, what happens to the other, and then how biological sex kind of like factors into that after. So you're going to see questions like this on exams. So yeah, we'll definitely go over this one a little bit, but I'll just give you guys a little bit of time. All right, so this one seems to be giving you guys a little bit of trouble. Okay, so there's a positive relationship between height and weight, regardless of sex. So basically, as one gets taller, they tend to get heavier. And then when you factor in biological sex, the men tend to be both taller and heavier than the women. So I hope this kind of makes sense. If you have any questions, ask them now, and I'll try and go over them with you. Um, Yeah, you all probably did just overthink that one. Sorry if the question was a little vague. Um, just trying to make this like as close to exam conditions as it might be. Next time I'll try and make a vague question a little bit more multiple choice for you. So anyway, I'll continue on. So basically, this is a bunch of different uh, box plots. So which group has the highest median or largest median? Sorry. All right. Yep. You guys are right. It is special admissions because you can kind of see on the graph that the median, which is just right here, goes down. So I guess that's about 94. So it's got the highest one compared to charter, which is 93 and all that other stuff. So good job, guys. And I believe this is the last question. So give you guys a little bit of time. All right, way to round out the night. Yep, it's video games because you can see it goes from 0 to 14, whereas exercise only goes from 0 to 12. So is that you're probably going to see, graphs like these where it's asking you to compare, whenever you're going to see the side by side graphs or, the graphs that have multiple different things, it's going to be asking you to compare. So, just comparing this and the last one, comparing the median, stuff like that. So, as long as you guys, are familiar with what they're asking, you should be completely fine. So, all right. And with that, thanks for coming out to my session tonight. If you have not already, just please enter your PSU ID in the chat. And my next session will be this Sunday. It's going to be the exact same thing unless any of you have any burning desires for new questions or stuff like that, in which case I will edit it a little bit and make it a little different. But also, this presentation will be put up on YouTube, so you guys can look at it if you need, and all the other people who didn't come to this presentation. So